Hello, everybody. Welcome to my talk on the Africa Quality Del Air Network. My name is Subramanian, and I usually go by Subu. My core research team members are Mike Giordano and Julian Bahino, and my host in France, Dr. Matthias Beekman, as well as, of course, a collaboration with many partners around the world, Kofi Omega, Becky Garland, Jimmy Gasore, Peter Van Zyl, Stuart Pickett, and many, many more. The funding for this project, a lot of it for me personally came from the Make Our Planet Great Again program managed by the French ANR. We have also received funding from the Carnegie Mellon College of Engineering and the Columbia Center for Climate and Life. And like I said, we are partnering with many educational and research institutes around the world. The motivation for this work is the fact that air pollution is responsible for nearly 5 million deaths in 2017, according to the Health Effects Institute. And air pollution really causes a lot of diseases: lung cancer, ischemic heart disease, chronic obstructive pulmonary disease, respiratory infections. So we need to not only monitor air pollution, but also identify and quantify the sources. The traditional way of monitoring air quality is with reference grade monitors, which are highly accurate, but also highly expensive and require a lot of maintenance. The alternative are what we call lower cost monitors, mini stations, which are essentially made up of low power, low cost sensors, but these sensors can be affected by temperature, relative humidity, and can be cross sensitive to other pollutants. And talking about the state of air pollution monitoring around the world, this plot here shows on the y-axis the estimated PM2.5 annual average concentration for different regions around the world, and on the x-axis the number of PM2.5 monitors in that region per million people. And what we see is that many parts of Africa are expected to be extremely polluted, but have very little in the way of ground monitoring. And many countries in Africa lack official air quality monitoring networks with reference grade monitors. There are a number of US embassies in Africa that are now installing BAMs as of this year, but that's usually only one per country. And the fact is that pollution can vary not only across a country, but across a city, and that's why we need a lot more monitors. And one way that we are working to overcome this gap is with the use of low-cost sensors like the real-time affordable multi-pollutant monitor, or RAMP. The RAMP was developed by my team at Carnegie Mellon in collaboration with a private company, Sensit, which is now owned by Sensavir, which is now owned by Sensit. And it uses Alphasense electrochemical sensors and nephelometers for PM2.5. It has GSM communication and an onboard SD card. We have published a number of papers on this, on the calibration and the use of these sensors. And thanks to the MOBGA support, we have now deployed these ramps in many countries around Africa. Here shown some pictures of our installations in Niger, Kenya, Cote d'Ivoire, and South Africa. And of course, we always work with local partners for each of these installations. Now, speaking of the state of air quality monitoring or studies in Africa, this map, the base map here, shows that is compiled by Dr. Julian Bahino, shows recent studies in different parts of Africa. But as you can see, many countries in Africa, there is no air quality studies being done. And even for countries where there is some data, it is only a periodic study or like a short-term study and not really a lot of consistent monitoring, except for perhaps South Africa. And so we have deployed these low-cost sensors in many of these countries. Each image shows a country where we've deployed monitors, whether it's a Sensit ramp or whether it's a PurpleAir monitor or a Clarity node. And in addition to the low-cost sensors, we've also deployed reference-grade NOx and PM2.5 monitors in Abidjan, Nairobi, and Accra. And so now, turning to the results, like I said, South Africa is a country where there are a lot of reference-grade monitors already in operation. So we leverage that fact to test the importance of different calibrations. Now, in a lot of other countries in Africa, there are no reference monitors. So what do you do in that case? Well, can we use a published model, like, for example, the general model developed by the US EPA for the USA? And we also have a collocation at Belhun Station, which is a rural background site where the average PM2.5 concentration is about 14 micrograms per meter cube. And it's a rural background site, like I said, with high in organic compounds. We then test these calibrations as well as develop a local calibration for Zamdela, which is a semi-urban low-income settlement where Stuart Pickett has a reference monitoring station. And so we tested different calibration models at Zamdela, along with a localized calibration model built at Zamdela. And we used 3 metrics to evaluate the performance of the model. The first one is the mean normalized bias, where lower is better. The second is the bias corrected coefficient of variation of the mean absolute error, which can be a form of precision error. And again, lower is better. And the third is the correlation between the sensor output and the reference monitor indicated by the Pearson R. And in this case, higher is better. And so the raw data is seen to have a bias of greater than 40% and a bias corrected CVMAE of almost 80%. Whereas if you apply any correction, whether it's the US EPA correction or the South Africa corrections, the CVMAE reduces and the mean normalized bias also reduces, but the South Africa corrections reduce the bias even more than the US correction. And the localized Zamdela correction shrinks the bias to almost 0. The Zamdela correction also improves the correlation slightly. And so the takeaway is that when you deploy a PurpleAir monitor and you have no reference monitors, you should at least apply some sort of correction, whether it is the US EPA correction or some other nearby collocation-based correction, but a localized correction is obviously the best of all. And so we now go from South Africa to East Africa, where in Kigali, we have been studying air quality since 2017. 2017-2018, we did a 16-month-long study, and we measured air quality at 2 sites 5 kilometers apart in Rwanda in collaboration with master's students from the University of Rwanda. And this is basically a summary of that study where we measured pollution across 5 different seasons. And the plot here shows the diurnal seasonal average, basically PM2.5 by hour of day for a typical hour of day across the dry seasons and the wet seasons. And what we find is that the dry season PM2.5 is significantly higher than the wet season PM2.5. And we believe this could be due to transported biomass burning or dust. There is a sharp diurnal pattern in any season, and typically the peak in the morning is seen at 7 or 8 a.m., which is likely due to the peak rush hour morning, the morning rush hour peak. There is also a peak overnight, which sometimes persists overnight, and this can be attributed to both vehicular traffic as well as domestic cooking emissions. This publication has been accepted by the Clean Air Journal. Now moving on to Kenya, which is another country in East Africa. In the early days of the pandemic, this photograph of Mount Kenya went viral, taken by Osman Siddiqui. And people are surprised that they could see Mount Kenya from Nairobi. That visibility was so good. And a lot of people attributed it to the lockdown, reducing air pollution. Now, April and May are also the wet season, so there are a couple of confounding factors there. Now, the question is, did air pollution really go down, which is why you're able to see Mount Kenya in the background. And due to the pandemic, there has been a curfew, mostly an overnight curfew in Kenya, in Nairobi. And so we show here the seasonal diurnal monthly patterns of PM2.5 for April through mid-July, which is when the curfew ended, and the post-curfew times, second half of July and August. Now, these data are from Clarity nodes. There are no local calibrations yet, but the BAM is on the way to Nairobi. But applying the US EPA correction, like we saw, any correction is better than raw data. And what you find is that the lowest pollution is seen in the April and May, the first 2 months of lockdown, which also are the wet season periods. And the highest are seen in the second half of July and August, which is the post-curfew times, but that is also the dry season. So once again, there can be 2 explanations, or maybe both the change in weather as well as the curfew contributed to the reduction, lower PM2.5 in April and May. We need to investigate this further, but the bottom line is that when that photograph was taken, the pollution levels in Nairobi appear to have been really low, which is why visibility was so good. So moving on to West Africa, we have some results from Abidjan where we compared the ramp at the Felix Houphouët-Boigny University with the US Embassy BAM that's 2 kilometers away. And they seem to pick up similar peaks. So at least maybe with the US correction for the ramp, so maybe it's okay. But if we do a scatter plot, the agreement is not so good. And so we need a localized calibration. And as of a couple of weeks ago, we have set up a BAM at the Felix Houphouët-Boigny University. And that's Dr. Julian Bahino after installing the BAM. And hopefully we will soon have a localized collocation-based calibration for the PM2.5 measurements in Abidjan. These are some recent data from Accra, Ghana, where we have a reference NOx analyzer. And we will be collocating ramps with the NOx analyzer for localized calibration of the ramps. We haven't talked about satellite data, which is another really useful tool in our arsenal to study air pollution across Africa. And we actually see a decent correlation between tropomi NO2 and our surface NO2 concentrations. And so there is promise to combine the ground measurements with the reference monitor and the ramps with the satellite data to improve our knowledge of air quality across Africa, especially West Africa. And so ongoing work and next steps, I'm running out of time, but please visit our website and connect with us on Twitter. But we really need more reference monitors across Africa. We need a lot more funding for that. We have a lot of great partners. And so we encourage you to reach out to us, especially funding agencies, to support this work. Thank you for your attention.